numbers, conjugates, and quotients. I'm going to work through several different problems here, so pay attention to the time on the links that I'm providing so you can fast forward if you need to. Excuse me. So this first one says, multiply the following complex number by its conjugate and simplify. And so the conjugate of a number, a complex number, let's say a plus bi, its conjugate would be a minus bi. And so it's just the imaginary part switches signs, and that's it. Otherwise they're the same. So one's plus, one's minus. So in this case, the conjugate of negative 7 plus 6i is negative 7 minus 6i. And so if I multiply those out, and I can do this in a number of different ways. I'll do this one just with the kind of the distributive property. Negative 7 plus 6i times negative 7 minus 6i. And so the first product I would get is negative 7 times negative 7. That negative times negative is positive, so that's 7 times 7, 49. And then I've got negative 7 times negative 6i. Again, negative times negative is positive. 7 times 6 is 42. I've got 42i. And then I multiply 6i times each of those. So 6i times negative 7, that's minus 42i. And finally, a positive 6 times a negative 6 is negative 36. I times I is I squared. Now, these two, they just are opposites of each other. So when you add a number to its opposite, they get 0. Those just cancel each other out. So I've got 49 minus 36. This is the same, I squared is the same as negative 1. So I swap that out. So what I get as a result is 49, negative 36 times a negative 1, that's plus 36. And therefore, 49 plus 36 would be, 85. Pretty sure. Let's see. 49 plus 36. Yeah, 85. All right. So that's 250 here. Simplify the following division of complex numbers. 4 minus 5i divided by 10i. And so when you're doing this, you're going to go back to the conjugates. And the conjugate of that of the denominator, 10i, is just negative 10i. But I need to make sure that the top and the bottom are the same, because then negative 10i over negative 10i is essentially equal to 1. When you multiply by 1, you're not changing the value of the number any. You're just maybe changing the way that it looks. So here, I'm going to distribute negative 10i times 4 would be negative 40i. And a negative 10i times a negative 5i, negative times negative is positive. 5 times 10, 50, and I times I is I squared.
All those running for class office.
And then I've got 10i times a negative 10i. A negative times a positive is negative. 10 times 10 is 100, and then I have I squared. I'm going to switch places between these two because our standard form is a plus bi, where a is the real part and bi is the imaginary part. And so I'm going to switch places here because that I squared is negative 1. This I squared and this I squared gives me 50 I squared. That becomes 50 times negative 1. Now that is real. Negative 40i, that's my imaginary part. And then negative 100 times I squared, that's negative 100 times negative 1. Just swapping those out and moving places here. So what do I get as a result? Negative 50 on the top minus 40i, and then negative 100 times negative 1 is a positive 100. Now, you could say, hey, we're done, but what's the real part here? Remember, all of this is being divided by 100, and that's the same as saying I've got negative 50 over 100, and then minus 40i over 100. And then you can simplify this if you just know how. You know that negative 50 divided by 100 is negative 1/2. But you can show that in a calculator. If I put negative 50 and I divide it by 100, it gives me negative 0.5. But then if I hit math, enter, it gives it back as a simplified fraction. So negative 1/2. And then negative 40 divided by 100, same idea. Negative 40 divided by 100. I'm just ignoring the I. And that gives me negative 0.4, which when I hit math, enter, that's negative 2/5. So minus 2/5 I. Again, I just ignored the I. And so that is what this looks like. Now, for the answers that we gave, if we go to the end of this, we wrote both of them. Let me see here. Let's see if I made a mistake. I think I made a mistake on the answers here. And so the answer on this, this should not be 4, it should be 40. So minus 40i, in which case this is not correct either. It's negative 1/2 minus 2/5 I. And that's what I had up there, I think. All right, so there's that. Let's go on here. This is simplify the following division of complex numbers. It's got 5 minus 2i over 4 plus i. Once again, we're going to multiply by its conjugate. The conjugate here is 4 plus i, 4 minus. It's the conjugate of the bottom of the denominator. The top has to be the same, 4 minus I. And so then I'm going to multiply. Let's use the kind of distributive property. 5 times 4 is 20. 5 times negative I is negative 5i. And then negative 2i times 4 is negative 8i. And negative 2i times negative I. Negative times negative is positive. 2 times 1 is 2. And I times I is I squared. So that's what you get along the top. On the bottom, you got 4 times 4, which is 16. 4 times a negative I, that's minus 4i, plus 4i. And then I times a negative I, negative I squared. And again, these, I'm going to write them as kind of switching places. So there's those. I've got 20 plus, let me move this a little bit. 20 plus 2 times negative 1. That I squared, there's your negative 1. And then negative 5i minus 8i would be negative 13i. Let's show that here. Negative 5i, negative 8i. There's my negative 13i. These two, negative 4i plus 4i, they just cancel. And then I've got 16 minus negative 1. Again, there's my I squared. That's negative 1, but it is being subtracted. And so I've got 16 minus negative 1. That's the same as 16 plus 1. This is all here as a fraction. So then we can write that I've got 20 plus negative 2, or 18, minus 13i, and this is over 16 plus 1, or 17. Now, I'm kind of basically done, except for if I rewrite this to determine what are my real parts and what are my imaginary parts, I'm just going to have 18 over 17, which cannot be simplified, minus 13 over 17i. And that would be our final answer. All right. Let's go to this last one here, mastery here. Simplify the following division of complex numbers. Once again, we're going to multiply by its conjugate of the denominator, negative 5 minus 2i, negative 5 plus 2i, negative 5 plus 2i. And then I'm going to distribute here. Bump, bump. 1 times negative 5 plus 2i gives me negative 5 plus 2i. And then 3i times negative 5 is negative 15i. And then 3i times positive 2i, that's 2 times 3 is 6, so this is plus 6i squared. All of this is over negative 5 times negative 5, positive 25. Negative 5 times plus 2i would be negative 10i. A negative 2i times a negative 5 would be plus 10i. And then a negative 2i times a positive 2i is negative 4i squared. I'm going to highlight my I squared, so remember to take those out. As a result, I get negative 5 plus 6 times negative 1 plus 2i and minus 15i would give me negative 13i. And then this is over on the bottom, 25. These both are going to cancel. And you've got minus 4 times negative 1. We combine these that can be combined. 6 times negative 1, that's negative 6. Negative 5 minus 6 is negative 11. Minus 13i, and this is all over 25 plus 4, because negative 4 times a negative 1 is plus 4. So this is all over 29. Now, to rewrite this, I would say this is negative 11 over 29 minus 13 over 29i. And that would be our answer. You want to check to see if you can simplify this, let's say. Well, both those are prime numbers. They don't have anything in common, so they cannot be simplified. But you want to check, ask yourself, can I simplify the fractions? If you can, you should. And that's kind of how this goes. All right, well, keep working hard. You got this.